So welcome to the MdynamiX Innovation Portal. In today's episode, we will be looking at active sound generation and active noise cancellation with electric drives. Many electric drives and actuators today face two issues. Either everything sounds emotionless or it becomes annoying due to whining, humming or buzzing. And that's exactly where we step in with active sound generation and active noise cancellation.
Thank you for the introduction, Annika. Yes, the basic idea is to use electric drives as acoustical actuators, which means there are additional functions we can use. The first one is the so-called active sound generation, ASG, which means we really want to regenerate sounds. And the second one is the active noise cancellation, where we will reduce some disturbance noises.
Okay, so what can ASG be used for?
The ASG function can be used for many cases. In many cases, we can shape the sound from electric vehicles, the whole electric vehicles, which means we can generate some brand typical sounds. And we can do this without any additional hardware, as we use the electric drives itself as acoustical actuators.
So, can we hear it?
Of course, I prepared something. So, what you can hear right now is really generated by the electric drive itself, which means we use the magnetic forces in this case air gap of the electric drive to modulate the housing of the electric drives and generate some vibrations and finally some so-called airborne noise, which you can hear right now.
Okay, and I can also feel it when I touch it.
Right,
okay.
You can also feel some vibrations. Mm-hmm. We call it structure-borne noise in this case.
Okay, and do we need some additional hardware for this?
No, we don't need any additional hardware for this additional function. In typical applications, the electric drive is equipped with some power electronics and with an electronic control unit, and we can just place one additional piece of software on the electronic control unit and use the already installed hardware to generate some audible sound and some haptical feedback, for example.
Okay, so speaking of haptics, can I generate perceivable vibrations in addition to audible sound?
Yes, right. You can generate both. So it depends on the frequency, what we generate. Let's say in the higher frequency range, we can generate some audible sounds. And in the lower frequency range, we can generate some vibrations, which you can feel when you touch on the drive itself or on some coupled structure what's around the electric drive. In a car, for example, you can feel it in the interior of the car.
Okay, so does it work only inside of the car or also external?
Both are possible. It depends on the mounting point of the electric drive, which means some electric drives can be used to generate sounds outside of the car to warn pedestrians, for example, and some electric drives can be used to generate noise, sounds or vibrations in the interior of the car.
Okay, so maybe parking beeps or other signal tones would be also possible.
Yes, right. As you heard in the demonstration, we could really generate nearly any kind of sounds. So we can really generate any shapes of sound. So which means, for example, some tonal sounds like parking beep, and of course much more complex sounds.
Okay, so now we've seen that this technology can create sound very efficiently. How do we use this to reduce unwanted noise and enable active noise cancellation?
So yes, the basic principle is quite easy. So we just use the generated sound and adapt the phase and the magnitude in a way to get a compensation signal for disturbance noises. From technical point of view, it means, for example, for a sine wave, we have the same amplitude and we shift the sine wave with the same frequency by 180 degrees to just that the sum of it is 0.
Okay, is there also something we can hear right now?
Of course, I prepared something. So I will start the primary function of the electric drive, and what you can hear right now, it's the natural sound of the electric drives. Of course, there are some permanent magnets inside, and this permanent magnets leads to a force on the stator of the electric motor, and this leads to some, let's say, pumping of the electric drive, and this is what you can hear right now, the disturbing noise. And now I will just switch on our algorithm. And you can hear the disturbance noise is really reduced. I will just do it again. Now it's the natural sound, the algorithm is switched off, and now it's switched on.
Okay, so does this also work for other applications, home applications, or for example, heat pumps?
Yes, of course. I will just stop the background noise. Yes, of course, it works for any device where at least one electric drive is installed.
So if the motor is generating sound or counter vibrations, how much does that affect the efficiency?
Yes, let's start with the ANC part. We just saw in previous cases that we could increase the efficiency of the electric drive by using the ANC algorithm and reduce some disturbance noises. And in the ASG case, we of course need some additional power to generate this acoustic power. But in typical applications, it's only a really small amount of the power which is needed for the primary function of the electric drive.
Okay, so with one and the same technology, we can make the driving more emotional and solve NVH issues at the same time.
Yes, correct. We can use the ASG function to generate sound and create emotions, and we can use the ANC function to suppress some disturbance noises.
Okay, so if you are developing vehicles, home appliances, or any other products with electric drives and want to shape sound or get rid of noise, reach out to us. We are happy to discuss how this can be transferred to your system.